Hi, I'm Eli Dorado. I'm chief economist at the Abundance Institute. And my talk today is on why are we stagnating? So the first part of the talk is convincing you that we're stagnating. And this is like the dark Steven Pinker talk. The metric that I focus on the most, that a lot of economists focus on the most, is total factor productivity. This is roughly how much output are you getting for a given amount of inputs into the economy, right? And so this is the trend in the US. This is a series from the Federal Reserve Bank of San Francisco. I love it because it's quarterly. It's pretty good methodology. And, it looks like a bunch of squiggles, but if you just plot like the pre-1973 trend, we should be up there. This trend actually, the data is not as good, but it goes back further till about 1920. It's about 2% a year. And if we hadn't stagnated, if we had kept growing along this trend, GDP per capita would be about twice as high as it is today, not just from TFP, but probably from capital deepening as well. So you should think of like, if this trend had continued, we would be twice as rich as we are. So this period is called the Great Stagnation. We are still, I think, living through it. And in fact, the last couple of quarters have had negative TFP growth. So we're not out of it yet. Some people don't believe in economic statistics. And so, I'll just go through a few physical statistics. So this is US primary energy use per capita. And it peaked in 1977, 1978. This is also known as the Henry Adams curve, made famous by J. Storrs Hall. But we're consuming about a third of the energy per capita that we would be if previous trends had held. And this is a trend that goes back to 1800 to 1974-ish, okay? Maximum commercial transatlantic speeds. This is a subject near and dear to my heart. The first transatlantic service was brought into being in 1939, our direct transatlantic service, not on a flying boat. And we had Concorde from 1976 to about 2003. Now we're cruising, in the 500s-ish miles an hour. And if the trend had just continued from before, we'd be flying at Mach 4 across the Atlantic. So we're stagnating in speeds. And drug development costs, this is a fun one. So this is just, number of new drugs approved divided by industry R&D spending. Obviously, it includes a lot of drugs that failed, that didn't make it to market, but 2012 dollars, so adjusting for today's dollars, closer to $2 billion a drug. And we would have a lot more drugs, obviously, if the costs were still as low as before. So my contention, and it's a bit controversial, is that innovation economists have been barking up the wrong tree a little bit on this. So it comes down to ideas. And I think there's an undeniable component in which prosperity comes from ideas, right? If you think back to 1600 versus today, we are much wealthier today, and some of that comes from ideas. We've had so much scientific advancement from then to today, and we've built on that, and we have created the prosperity that we do have on the back of that discovery. So this is kind of, I think, the standard innovation economics view. I've cited a few papers here. I think these are all great economists. This is the main view. TFP is more or less ideas. New ideas are proportional to the number of researchers times research productivity. Robert Gordon's a great economic historian. He thinks that 20th century innovations are unrepeatable. And I think there's good evidence that, at least in some fields, research productivity is declining. A conclusion that is often drawn from like taking these sort of this part of the literature together is that the decline in TFP growth that we've had since the 1970s is not really surprising. It's not a problem to be solved. It's kind of what you would expect. A way to summarize it is we've picked the low-hanging fruit, and ideas are now getting harder to find. And I think that's wrong. So problems. Let's lay some out. So Thomas Edison said genius is 1% inspiration and 99% perspiration. I think TFP growth is 1% having new ideas, 99% implementing and scaling ideas. So this is maybe not true in all states of the world, but I think at current margins, I think this is where we are. Another way to think about it is that before an idea can affect TFP in the first place, it has to be first invented and discovered. Then it has to make some sort of contact with the real world. Then As a result of that feedback, there's an iteration loop that has to happen where it gets refined and perfected. Then it gets deployed on the market. And then last step, it has to scale. Because if it doesn't scale, you can't affect GDP in any meaningful way. And if you can't affect GDP, you're not affecting TFP. And as we'll see, there's obstacles to all of it. Another issue is the ideas are not uniformly getting harder to find. We're having a golden age in biology right now. There are grad students in our university labs who can do more by themselves than what the most eminent biologists could do 50 years ago, right? So ideas are getting easier to find in biology. Now, it's not necessarily translating into medical advances. Medical advances are moving more slowly, but in biology, we're having a golden age. So it's at least one place where ideas are getting easier to find. And there are maybe others. It would be weird if we had this million-fold increase in computing productivity, and that didn't open up any new vistas or new paradigms in other fields. This is kind of a little cheeky. Are ideas getting harder to remember? So interestingly, if you break total factor productivity growth down by industry, you see that there's a lot of variation. So computer and electronic products, off the charts. Support activities for mining, that's fracking. Computer systems design and related services, very high. Air transportation, software, all pretty good. But then you get down at the bottom here and you see things like hospitals, construction. There are entire sectors of the economy where you have significant negative productivity growth. You kind of have to admit that like maybe ideas are getting harder to remember. And to put a finer point on it, here's Italy. They've actually had negative TFP growth since 1979. Brazil, from 1980, minus 37%. I was born in Brazil, so it's all downhill since the year of my birth, Brazil. Iran, and Venezuela. Just brutal declines. I don't think any of us think that really what's going on here is that they've forgotten a bunch of ideas. We think it's institutions, right? And development economists will tell us that ideas are more or less the same everywhere. So countries are rich or poor because of different quality of institutions. And the quality of institutions is what mediates the translation of ideas into output, right? And so if that explains the cross-sectional variation in differences in TFP, then I think it needs to be the null hypothesis for what explains the intertemporal variation in US GDP. So another way to put this is that ideas are getting harder to use. Here are the rules. The US is the land of the free. You can do anything you want as long as no one is inconvenienced, no one can possibly get hurt, and no jobs may be lost. So anything else, anything at all that you want to do other than those things. We talk about this as vetocracy, as preemptive safety regulation, as protectionism. I'm sure many of you recognize this image. This is Starhopper. This is the very first variant of Starship. This was launched 5 years ago out in Texas. They went out in the desert and took this like cute little water tower thingy. And from that came this just the other day. Gorgeous image. I'm sure many of you watched this. It's a testament to the importance of iteration, being able to try things and learn from them and try again and go through a cycle of refinement and gathering data. Well, what is the Starhopper of nuclear? You know what it is? It is a fully NRC licensed reactor. That is the smallest thing you can build. So that means that we've cut off the iteration loop for nuclear at a very early level. You cannot go out in the desert, build a small reactor, test it to failure, figure out what systems you can delete, what's redundant on it, try out new materials. You have no cheap way to experiment in this field. And what has happened? We were producing nuclear for about $1 a watt in the 1960s, and now it's significantly more. And if you put the new Vodal reactors on this chart, it would be off the chart. It is $15 a watt or something like that for the Vodal plants. So there's no law of physics that says nuclear has to be as expensive as it is, but if you cut off the possibility of iteration, that's what you end up with. Another issue with safety regulation is it's often inconsistently applied. So we have incredibly stringent nuclear regulation that results in 0.03 deaths per terawatt hour of electricity production. And meanwhile, we have coal plants that are far more fatal. We have about 5 9/11s a year from coal exhaust in the US. And these safety regulations make no sense. Why would you regulate nuclear so stringently and coal so laxly? Like, you would think they should be similar, right? This is also a problem with FDA regulations, right? Like, experimental drugs and devices is very hard to get access to them. But the existing standard of care, which is often very dangerous, it's fine. It's allowed. To switch gears a little bit, housing. This house, I just picked it up off of Zillow earlier this week. 896 square feet, $2 million. It doesn't have to be this way. We know how to do this. We know how to build cheaper housing, right? No new ideas needed. Along similar lines, this is an environmental assessment for a project that was done recently in New York. This is the Central Business District tolling program. So this is where they're going to have congestion pricing in Manhattan. And this environmental assessment delayed the project by 3 years. After it finished, there was a lawsuit from New Jersey because they didn't like it and they could sue on the grounds of this environmental assessment. And then because it was delayed so long and because it was starting to coincide with the presidential election, the whole thing got canceled. So after doing this much paperwork to produce a report that no one has read cover to cover, to decide whether congestion pricing is bad for the environment, the entire project was canceled. This is how many environmental assessments it takes to develop a geothermal project on federal lands in the United States. So 6 different times you have to do environmental analysis, potentially, to develop a plant. This is Concord. We had this. There's no new ideas that we need to have this again. We could have this again, and I think Blake might be around today or tomorrow, and he's trying to bring this back. We could get it back even faster if we allowed supersonics to fly over land, right? We could have a low boom standard that would turbocharge investment in the industry, and we could have a thriving supersonic market. This guy, you guys know this guy, right? This is Harold Daggett. He's president of the International Longshoremen's Association, and they just went on strike. The strike got put on hold, but what they were arguing about was whether they could automate port operations, the containerized port operations. And actually, they were not even arguing whether there would be automation. They were arguing about whether there would be semi-automation, because automation is already excluded by the contract that they were under. Purely a protectionist measure that lowers productivity. And it's not just the Longshoremen Association. This is a picture of a contact lens vending machine that exists in Latvia, and you don't need a prescription. You can just go to the vending machine and buy whatever contact lens you want, right? But the optometrist union, I don't think that's a real thing, but like the optometrist unions have lobbied to introduce a prescription requirement so that they can get their taste before you are able to get contact lenses in this country. So the world is definitely not efficient. I have a few conceptual graphs. You can quibble with the actual positioning of the points on these graphs, but affordable housing versus neighborhood character. People think that we have a trade-off between these things, but actually we could have both. We could have more of both than we have. We're not on the efficient frontier. Number of drugs on the market versus safety. We could have more of both. Quantity of energy harnessed by humanity and environmental quality. We can have more of both. It's not a trade-off. We can have more industrialization and more biodiversity. And we can have more efficiency and we could have more equity. Those are not inherently in conflict the way people think that they are. So how can we fix it? I'm going to give you a recipe. I'm not saying it's the only recipe, but this is kind of how I'm thinking about it lately. And it involves 3 steps: technoeconomics, sociopolitics, and entrepreneurship. And I'm thinking about entrepreneurship here in a particular way. I got this definition from Tom Khalil. An entrepreneur is someone not limited by resources under direct control. So you can be all kinds of entrepreneurs. It doesn't mean you have to be a businessman or a businesswoman. And so what I think we need to do as a community, as a movement, is develop a concrete vision for the future that we want. We have to identify what the obstacles are to achieving that vision. And then we have to use our entrepreneurial ability to obliterate those obstacles. And I think that we can do that. And I'm excited to work with all of you on this for the next several decades.